Hi there, this is a second video on proofs. These are a couple that I got out of the textbook, and let's just get to it. So I got my statement and my justification, and instead of trying to put this into words, I'm just going to write diagram, and that is our given information. All right, so we want to show that, let me get my highlighter. This one, and this one, and this one are all parallel. So let's start by just looking at the top two. So to show things are parallel, this is the converse of some of those, the converse of what we usually say. We usually say, oh, the lines are parallel, so the angles are equal. Well, this is going to be the angles are equal, the lines must be parallel. So we got a couple of choices, and seriously, I'm going to keep my hand like this because otherwise I start looking at the other diagram and it starts to weird me out. So where do you see numbers that are the same? Well, you've got a 35 here and a 35 there. And if you think of these as being the parallel lines, and you think of this as the transversal, then the 35 and the 35 are alternate interior angles. So if alternate interior angles are equal, then the lines are parallel. And if you're wondering, I could also have talked about the 78 and the 78. These two are corresponding angles, and they're also equal, so the lines are equal. Either one would do. I saw the 35 first, so I'm going to use that. Oh, goodness. Since the angles are not labeled off with numbers, I guess I better write them out. So I want this one first. So it's C to G to B. Angle C, G, B is equal to angle G, B, F. And hold on, I'm going to do this exactly right. Is 35 degrees. Angle G, B, F is equal to 35 degrees. How do we know that? Well, that's given in our diagram. So then we know angle C, B, GB is angle G, F they're both equal to 35, right? Transitive property of one. If two things are equal to a third, then the first two are equal to each other. So that means CG is parallel to BF. Now, I'm not really sure. Normally, with geometric proofs, you'd add that in there to show that those are the line segments that you're using. I noticed they didn't up in the question, but whatever. I'm trying to be like super good with this geometry. Because now we said the 35 and the 35 were alternate interior angles are equal, so lines are parallel. All right, now if we look at the bottom part of the diagram, you see any angles that are matching? Yeah, see the 22 here and the 22 there? Ta-da, exactly the same theory. Those also are alternate interior angles, and the work is going to be exactly the same. So How about you turn the video off right now, squish in the rest of that proof in that little space, and then turn the video back on and see if we agree with what we said. Okay, trust that you did that. So in this case, I'm looking at these 22-degree angles. So angle FBE is equal to 22 degrees. Angle AEB and just like before, that was given in the diagram. So those two angles are equal. So I just want to double check. So it's F to B to E, yep, and A to E to B. Good. That'll be transitive. Oh, I'm so running out of room. What do we do after that? Oh, we were already at the point where we can say them they're equal. So BF. I don't know if you guys have been watching my videos, you know I usually don't do pencil unless I'm doing proofs. Line segment BF is parallel to line segment AE. And we said that's because alternate interior angles are equal. So lines are parallel. I would probably consider that whole proof done at this point, but just because. Oops, let's make it exactly what it wants us to prove. C, okay, I'm gonna put there, CG is parallel to BF is parallel to AE. And I'm gonna say that's transitive. I'm actually gonna look that up in the algebra later to see what they said. But to me, if if two items are parallel to a third, then they have to be parallel to each other, just like the lines on a sheet of loose leaf. Yeah, do not give up on proofs, okay? It's more, think of it in terms of a puzzle to figure out than, oh, I gotta do math. Right? If you think that it's a puzzle, like, I don't know if you like doing Sudoku or something like that, it's kind of the same thing. All right, proof number 2. And all right, so we're given that A, B, and DE. So this one and this one are parallel. And DE is parallel to the middle one. All right, show that angle ACD, so A to C to D, so it's this one, is equal to angle BAC, B is equal to that one. I'm going to do this 1, 2, and CDE, CDE, okay. Three. I cheated. Putting those numbers in there just makes it so much easier for me to remember, because otherwise, honestly, what I do is every time I have to look at one of those, I'm going, which angle is that again? Which angle is that? So angle 1, angle 2, and angle 3. So we're trying to show that angle 1 is equal to angle 2 plus angle 3. All right, so statement. And justification. And my given, you know what? I'm going to copy it right there. AB is parallel to DE, and DE is parallel to FG. Given. So if you're having a really bad day and you don't know where to start a proof, you can always start by rewriting the given part. Now, what do we know? Well, I'm going to show you guys a trick. I'm going to take, I don't have to use my ruler, but it was sitting there. And I'm going to extend these lines. Anytime I have to do a proof that's got to do with parallel lines or something like that, or angles, I like to extend my lines. It makes, I don't know, it makes it easier for me. So right now, and you know what, I'm also going to, my little piece of paper, there. I'm going to cover that part up. If I look at that, what is the relation between this angle and part of this angle number one? Yes, those are alternate interior angles, and we know those are equal. So this little angle is equal to the top part of that one. And I'm thinking this angle, right? So angle 3 is equal to the bottom angle down here. So that's our process. We're going to have to show that 1 is equal, that angle 2 is equal to this top part here, and angle 3 is equal to that. And then these two angles are angle 1. So let's get to that. All right, we're going to do it right with the letters simply because I don't know, the numbering isn't even going to work that great because angle 1 is made up of these two little angles. So angle BAC, which is angle 2, is equal to, now let's figure it out. I want this one that I colored in up there, so it's FCA. Okay, and that's because they're alternate interior angles. And we might as well do the other one. So angle 3, which is EDC. Oh, look, they said CDE, so go in the same order. CDE. And we're going to say it's this little angle down here, part of angle 1 that I didn't color in, DCF. And that's going to be ditto marks. All right. So now, I guess we have to say that angle 1 is made up of those two partial angles. So angle ACE. I'm going to fess up. I'm not sure putting the numbers in there helped us at all with this one. ACD, so A to C to D. So this big one that we've called 1 is equal to angle ACF plus DCF. And now I'm thinking I should have done this ahead of time because now I can't think of the reason. You know, two small angles. Make a bigger one. We'll just say adjacent angles. They're adjacent, they're side by side. So angle ACD, now angle FCA, ACF, and FCA are the same thing. So what we're going to do is we're going to substitute that one, which is the angle we want, And we're going to substitute for this one. CDE is the same as that one. Oopsies. And that was by substitution. All right. With the homework, okay, sorry. End of the proof. We're done. We got what we needed up there. Check what's on the front page of the worksheet. There was the very first page of this unit, there was something that had your assignments, the hand-in stuff that you had to do, and the homework at the bottom. It might be slightly different than this because I printed these off and I don't want to reprint them. All right, anyway, end of the video.